Talking about classes. Chapter 9. The attributes and behavior of a class. The attributes of the variables and the behaviors of the functions, the methods. So, programmers who use objects and classes know the interface that can be used with a class, the state of the object, and how to instantiate a class. This is all fancy words. The interface of the methods. The interface gives you the ability to work with a class, like the turtle dot forward and dot left and dot right and color and all those functions of the interface of the class. And then the state of the object is its data, right? The turtle has its X position, its Y position, what angle it's going on, and so forth. And how to create a class. You have to know how to instantiate it. And creating a turtle is just as easy doing turtle equals, T is equal to turtle.turtle, parentheses in parentheses. So an object is an abstraction. It's a packaging of state, which is the variables, and methods, which are the functions, into a single entity. And the class definition is the blueprint that makes the object. You can have one blueprint and build 100 homes from it. The blueprint is the idea, the objects, the homes are the things you make from it. So we could have a class called student that when you created it, you instantiated it like this. So its init method would accept a string and a number to create a student object. And then you'd have some other methods, a get name, a get score. Looks like get score is accepting a variable number to return which score, So if they have 10 different scores or whatever, and then set score, so that you can set their first score, their second score, their third score, and so on, and a get average and a get high score, which you can probably just call dot max on a list in order to get that out. And then if you want to turn the student into a string to display, we can implement a string method. So Python classes are organized in a tree-like class hierarchy. You can have classes that are inherited from other classes that are inherited from other classes. If you're taking Java or C++, you'll get the idea that there's a root class, a superclass, called the object class. And then everything else from that is inherited from the object class. So the object class just has a few functions, but everything under it also has those functions and more. Now super doesn't mean bigger and better, it just means the top of the hierarchy. And then as you go on, you keep adding things to it. So the syntax of a method is similar to the syntax of a function. You just have to pass in that self argument. That has to be the first parameter. And just like any function, it returns none if there's no return value for the method. They can have required arguments or default arguments, and they can have return values, or they cannot have return values if you want them to not have any. And so most classes will have an init method. All of our methods inside the class will begin with the self keyword, followed by any additional data that the function that the method will need. This is known as the constructor for the class. The init allows the code to construct a new object. And it runs automatically when the user instantiates the class. Instantiate just means create a new object. So when we make a brand new student, s is equal to student 1, 5, we don't have to pass anything in to fill in the self. That reference gets filled in automatically by the compiler. And we are passing in this argument to give ourselves a name. We're passing in a number to give ourselves a number. And then so self.name gets set to name. And then self.number, that's kind of a silly way of creating a list of that length. Here's how I would do it. If you need to create an array of a certain length, you just do this. I want an array of integers. Now I have an array of 5 integers rather than writing a for loop, but whatever, same difference. So the instance variables are these things. That's an instance variable. It applies to an instance of the class. Every student has a different name. Every student has a different list. So this instance of the student has a name of Juan, and this instance of the student has a test score that's 5 long. And so the instance variables in complete, in toto, take up or comprise the state of the object. And so str will convert the object into a pretty state in order to be printed. Perhaps the most important use of str is just in debugging, so you can print your object out and see what it's doing. Because we've seen in the past that if you print an object out, all it does is print out an address, right? A memory address and a name of the class. And that's not very useful unless you provide an str method. So methods that allow a user to observe but not change the state are called accessors. And then methods that allow the user to modify the state are known as mutators. About time to actually crank up and let's play with this idea a little bit. What we're going to do is we're going to make a class that opens a file and reads from a file and produces a report. So here's what I want the data of the file to look like. For one thing, I want it to be able to ignore comments in the file. So this is what's going to be in our data file. I'm just going to save it and call it data.py. All right, so what are we going to put in it? We're going to put student ID as the first element. We're going to put their name. And then we're going to put a series of test scores. Whatever. Now I'm going to copy and paste that a few times and make some differences each time, right? Right, just making up different data. Do not bother copying my data, right? You're free to make up your own names. All right, now I have some data to play with. So what do I see here? I see several pieces of information of interest to us. Several things that might make up the state of a student object, including their ID, their name, and a list of scores. So what would be a good data structure to store this kind of stuff into? Well, the scores just ought to be a list, in my opinion. I'm not thinking anything more complicated than creating something that looks somewhat like their example, which is to have a student object with a name, an ID, and then a series of test scores. But then we could have another class, which was a collection of students. Or maybe we're just going to stick all that in a list and then print them out that way. There's no reason to make this overly complicated. So, what are we going to work on first? Are we going to first work on opening the file and getting our data out of it? Or let's go ahead and define the class that we're going to use. So we're on V, I believe. So class student. As I mentioned last time, it's always a good idea to begin your class names with an uppercase letter just because that's the convention. That's what programmers all over the world do, and we're at least as cool as they are, if not more, so we want to do that. All right, so we need an init method that's going to take some pieces of information. Guess it could take all three of these things. I guess it could take a student ID, a name, and a list of scores. But let's just have it set the student ID and the name. So we need an init function, def. Remember 2 underscores, not 1 and not 3. Remember to put the space there. Underscore, underscore, init, underscore, underscore, parentheses, self, comma, name, comma, ID. ID is a bad one because it's coming up purple. SID, student ID. And then it's going to be self.name equals name, self.sid equals SID. And then for funsies, let's just print student object created, comma, name, comma, SID, just as a debug message. So debug, colon, student object created. And let's go ahead and create the list of scores, just so that we have some data to play with, even if no score data has been assigned. So we're going to create an empty list called scores. So self.scores equals either list parentheses in parentheses, or as we have been doing, we could just put these square braces, right, like that. So we need something that will let us add the scores to the student. And looking at this, looking at our data, it looks to me like the data is just going to be a list of scores. I mean, it's just going to be a list. So all the set scores function needs to be is accept an argument, which is a list. So def underscore set def space set underscore scores self comma score list in parentheses colon self dot score list equals score list. Now that's not really the best way to handle this. It looks like it. It looks like it'll copy the contents of score list into the score list data attribute, but it will not. Instead, it will copy a reference to it, meaning that we now have 2 pointers to the same piece of data. And so if we do set scores and we pass in a score list and then later on we change a value in that score list inside our main code, it is now also changed inside the scores. I almost kind of need to do a whole separate lecture on that. Just take it on faith for right now that I want to actually make a copy of the score list. I don't want to just put a reference in here. So I'm going to make a copy, and this syntax is going to look kind of silly. But starting at the 0th position and going out, and going all the way out to the last position, I want all of those elements. I want a slice that consists of all of those elements. We can shorten that syntax because, as we've said before, if we're doing slicing, if you leave the first number, it defaults to 0. And if you leave off the last number, it defaults to the last element. So we don't even need those numbers there. We're going to say, copy the list. So now I'm thinking that we might want a way of printing the data of the student out, and we might want a way to calculate the average. Averages are easy, so let's do that. Again, we're going to run into the problem that if we haven't set any data into it, we have an array length of 0, meaning that if we try to calculate the average, it'll blow up. So we may probably just put an if statement in there and hack it so that if there are no test scores, we say their average is 0. So DEF get underscore average self, not average, average. And why don't I just abbreviate it AVG because I can't spell. There. Get underscore AVG parentheses self in parentheses self. Let's check to make sure that the list is not empty. If the length of the list is empty, we're just going to return 0. So if len parentheses, kind of wish I'd chosen a smaller variable name than score list. If len parentheses self dot score list parentheses in parentheses equals 0, then return 0. That's for that rare case where the student hasn't taken any exams. Else, we're going to return the sum of the score list divided by the length of the score list. Else colon, return sum, parentheses, self dot score list in parentheses, divided by len parentheses, self dot score list in parentheses. And lastly, let's add a string method to convert this item into a string for display on the screen. And I think that what we ought to see is the name, the student ID, the list of scores, and the average. So DEF underscore underscore STR underscore underscore parentheses self in parentheses colon if we want to make it pretty, we would format all of the data out to the same width, right, so that it would line up nice on a sheet of paper on the screen. Well, maybe we can do that. Maybe this is going to look a little bit weird. Maybe we can get it going where it looks okay. So S, just being the return string, equals quote percent 20s. We're assuming that 20 characters is enough for their name. Space percent. Let's just assume that their name, that their student ID is going to be alpha. We're not going to do any math on it. So percent 10s for the ID. And now let's fill in those two pieces of data. So percent sign parentheses self dot name comma self dot SID in parentheses. Now let's tack onto that the list of scores. So I'm just going to concatenate to S the list of scores, and I'm going to use the join parameter, the join function, to create it. So S plus equals, let's go put a space right here, or we can just put it here. Quote, space, quote, plus, and I want all of my test scores separated by commas. So, quote, comma, quote, dot, join, parentheses, self dot, score list in parentheses. And let's tack on the average as our last thing. S plus equals, quote, An average could be 100.00, right? So percent 1, 2, 3, 4, 5, 6, 6.2f. Why 6? Because 100.00 would be 6 characters. And we want 2 decimal places because that's how we like to see our averages. So 6.2f. Put a space here. And then a close quote and a percent sign, and inside the parentheses self.get_avg, open paren, close paren, close paren. All right, we've done a whole lot of typing. I'd like to make sure that what we've got here will run. So I'm going to just create a simple test student and try to print it out. So S1 equals new student. The student's name is Joe Bob. And their student ID is 1, 2, 3, 4, 5, 6. Kind of lame to be passing it in as a string, but okay, whatever. And now let's print S1. That will exercise our class completely. No, it won't, because we haven't set the scores yet. So before we print it out, the next line needs to be S1.set, parentheses, and let's just pass in a series of scores. So inside the parentheses, do a square brace, and then type in some numbers separated by commas with a closed square and a closed parentheses. That should be enough to exercise our class appropriately to see whether we have syntax errors and the like. Yes, I do. Thank you for spotting that. It's no good to build a string if we don't return it. So the last line of the str function needs to be return s. Thank you.
Is there supposed to be a space between new and student?
Why don't we get rid of the word new entirely? Java rears its ugly head. Why am I getting an error about levels of indentation? Oh, because I'm one space over. Couldn't tell. Alright. Student object has no attributes set. Well, that's because the function is not called set. What is the function called? Called set underscore scores. So down here, this needs to be set underscore scores. Well, okay, my cheap way of printing all the scores on one line with dot join only works if the score list is a score list of strings and not numbers. So that's not going to work right there. So temporarily just comment this out. Or, yeah, go to the string function and make it look like this. The middle line of it, str self.score list. We'll just let Python turn the list of numbers into a string for us. But it needs a dot join function, which I keep forgetting does not work on numbers, just on strings. All right, here we go. Looks like we have our code working. Now, I don't want to go whole hog here, but the way the code is set up right now is that we can get access to these members really easily. if we wanted to, and I'll probably delete this, I could do s1.name is equal and give them a brand new name. You know, I could do s1.score list and give them a brand new list of scores. Just like Python doesn't have support for constants, and so we fake it by saying that anything in uppercase letters is a constant, Python doesn't have support for what is known as private members. Private members are variables that you can't change like that. I would not, if this was a language that supported private variables, be able to do s1.name equals whatever. I'd get an error if I tried to set the name and it was set as a private variable. So Python programmers have come up with the convention that if your variable name, and don't make this change, begins with underscores, then it's a private variable. And you're not supposed to try to access it from out here. So now, whenever I tried to change it, okay, great, but that wouldn't work. And then if I went and added the underscores there, I'd know, okay, why am I mucking with something with underscores in it? I shouldn't be doing that. So the idea of private data is data that you cannot access directly inside the class. And if you have private data, quite often people use what are known as accessors and mutators, which is that page on our PowerPoint. And those are just fancy words for getters and setters. I want something that allows me to get the name and something that allows me to set the name, and something that allows me to get the student ID and something that allows me to set the student ID. So those just kind of look like this. And if you don't want somebody modifying the data of your object after it's been created, you don't have to do this. But we already have a set scores. So maybe we're going to add a getScores method that returns the score list. And then we can add a setName and a getName method just for completeness. So I think I'm going to add a getScores. Oh, I said I was going to test it. I didn't check to see if y'all were doing okay on yours as well. So let's just tack on some notes before we go on. Class name should start with an initial cap. Class name should begin with a capital letter. If a variable should be private, start its name with an underscore. Now I didn't demonstrate that just because it would have made the stuff even harder to type than what we already have. Provide getters and setters for the variables, especially private variables. The textbook calls them accessors and mutators instead of getters and setters. So, accessor equals a getter, mutator equals a setter. So a class is a blueprint for an object, which is a collection of data, parentheses, quote, state, and functions slash methods, parentheses, quote, behaviors or interface. Don't you love how there's 20 different names for the same thing? So now we're going to add another class whose constructor accepts a file name, and this class is going to have a list of students, and then there's going to be a method inside that class which goes and opens the file and reads in the list of students. And then another member of the class which will print a report based on that. So why don't we call this one report? Class report. Oh, and up here where we tested our thing out, I guess we could leave that stuff here. But now that we know that it works, I think I'm going to comment it out. It's not a bad idea to have test code embedded in your thing so that if you make a change to it, you can find out immediately whether it works or not. Okay. I went ahead and commented that stuff out. All right, so class report colon the init function is going to take a file name. So def space underscore underscore init underscore underscore parentheses self colon self comma file name in parentheses in colon. Now we're going to try to open the file. I want to make sure that the file exists before we do anything with it, so I just wanted to remind myself of how we check to see if a file exists. And it's os.path.is file. So I'm going to add the import for that. Import os, and if os.path.is file underscore file name equals false colon, then it's a bad file name and we can't open it. So print report error open in quote comma file name. Else colon we will open it. Or we're at least going to store the file name for later purposes. So self.filename equals file name. Now let's test this one out. Test early, test often. We're going to try to create a report. RPT equals capital R report parentheses, and let's pass in what we hope is a good file name. If you created that Python file, that data.py file. All right. Good. It didn't blow up. We could print another debug message here. Print report object created end quote comma file name, just so that we see something happen. I'm going to go ahead and put debug in front of that. Debug dash just. All right. We can always come back in and delete all of those messages. All right, so here's how I want the function to work. I'm just kind of blue skying, so I'm going to put it in comments here. But I want to be able to do this. Report.read data, right? And then report.print report, or maybe just report.print. That may be enough. What's read data going to do? It's going to open the file, and it's going to add all of the data that it reads into the file. It needs to be appending them to a list of students. Well, we don't have a list of students yet, so we're going to have to add that to the init method. This is not really an exceptionally good way of handling the error, right? Because so what? They get that message. They don't know inside the program that it happened. I guess we'll have to handle that inside the read data method as well. It could return a false if it can't open the file. Okay, but we know that we're going to need a list of students because each element in the file is another student. So why don't we go ahead back tab to right there, and then let's do students equals Or maybe we should just call it data. Data is easier to type. It's 4 letters fewer. Data equals. That's going to be the list of students. Let's add a comment to that effect. Of students and their scores. So we're going to want a read data method, and what is read data going to do? It's going to open the file. It's going to step through the file line by line. If a line begins with a hash symbol, we're going to ignore it. That way we can ignore comments. Otherwise, we're going to read it in. We're going to call dot split in order to separate it by its commas. The first element is going to be treated as though it were the student ID. The second element is going to be treated as though it were the name. And the third one is going to be the list of scores. And then we can use that information to create a student object and add it to our list. So lined up with this DEF function, I'm going to add a new one. Define, or DEF space, read underscore data, parentheses, self, in parentheses, colon. And I've made a mistake, by the way. What should I have done to this variable? It needs a self dot reference in it to be made a part of the class. So self dot, please fix that, everybody, because whenever I make a mistake, and then later on when I walk around, a lot of the students didn't catch the fix because I didn't point it out while I'm pointing it out. That's the fix. Let's do that. All right. Maybe each time we call read data, it ought to reset that list rather than just adding it on. But yeah, let's do that. Self.data equals, we're going to just wipe the list out so that if they call read data multiple times, we don't have any old data. Reset the list, make it empty, and let's open the file. Now the urge is to put self dot in front of every single variable. You don't want to put self dot in front of every variable. The only variables that you want to put self dot are ones that are going to be used again inside of another function. This file variable that I'm going to create is not going to be used inside any other function. We're going to open the file, we're going to read from it, and we're going to close it. So we do not need to make it a self variable. We just need to do like this. File equals open parentheses self dot file name comma quote r end quote colon no quote r end quote in parentheses. Now let's process our file with a value-based for loop. For line space in space file colon. Let's split the line up. Let's trim it first and make sure that it's not an empty line, because that's a completely different kind of error, right? If there's just no data on it at all, we want to ignore it. So line equals line dot strip, which removes the white space at the beginning and the end of the line. And now we want to make sure that it's not empty. So if len parentheses line in parentheses is greater than 0, and line subscript 0 in subscript not equal to quote pound sign hash end quote colon, that means it's a good line. We could add a comment to the effect of what we're doing here. Skip all blank lines, and lines that start with that. the length of the line is greater than 0 and it doesn't begin with a hash, then it's good data. So we're going to split it. Line equals line dot split parentheses quote comma, because that's our delimiter, end quote, in parentheses. And so if we look at the format of our data, the first element in it is our list, our student ID. The second element is the name. And we're going to actually want to remove those so that all that's left is the list of scores. And that sounds like a job for the pop function. So let's do that. Name equals line.pop parentheses 0. Pop the first element. Get it, return its value, and remove it from the list. Or did I have that backwards? Is student ID the very first thing in it? Yeah, okay. So not name is equal to line. It doesn't matter, but anyways. SID equals line.pop. And then the next line will be name equals line.pop parentheses 0. Why 0? Because this removes the first element of the list. And so now the name is the first element of the list. And this removes that element of the list. And so all that's left now are the scores. And so scores is equal to everything else. You know what? I'm just unenchanted with the way that I've done this. We're going to do this a little bit differently. Sorry about that. I'm deleting both of those lines. SID equals line subscript 0. I want the syntax to look a little more familiar. So the student ID is the first element of the list. Name equals line subscript 1. The second element of the list is the name. And the scores equals line subscript starting at position 2 and going all the way out to the end. So 2 colon. Take a slice, ignoring the first 2 elements and then going all the way to the end. I like that better than messing with the pops. Now we need to create a student and add it to our data list. And we have everything we need to create a student. We have their name, we have their student ID. So S equals student, parentheses, name, comma, SID, in parentheses. I'm going to add a comment to the effect of, we have the info, now create the student object. We need to add the scores. So s.set underscore scores, parentheses, scores, or was it called set score list? Yeah. I feel like doing a global search and replace for the word score list and just changing up the scores, but all right. Okay. And now we need to add it to our list. So data.append, parentheses S. Back tab so we can put an indif comment. Back tab again so that we can be at the end of the for loop. And let's close our file. So file.close, parentheses in parentheses. I'm going to back tab all the way over here and put end class, right? And then this is going to be end of the report method. method, read data, the end of the read underscore data method, and this is the end of the report class. Now it doesn't print out anything yet, but I'd like to make sure it runs without syntax errors. Why don't we print a message here? Just so that we know that we read from the file. The link, let's print out the length of our list now. Print parentheses quote, data file, read, lines read equals, end quote, comma, LE in parentheses data in parentheses in parentheses. And this is a debug message, so I'm going to go and add the word debug to the beginning of the print statement. Alright, so report.read underscore data. After we open our file, or after we set our file name, we're going to read the data from it. And that's what this function is. That's what the method is. Data is not defined. Probably because I did not make it self.data. So right here, where it says data.append, it needs to be self.data.append. Please change that. And yet again, and on our debug message, make that self.data. So in that print data file read, lines read equals, make it len self dot data. You don't have to put it on a separate line like I did. I'm going to undo that. Try it now. Alright, so our debug messages are kicking into gear. Debug, the report object created, the file name is data.py. We created 4 students, the 4 people that I had in my data file. Yours will probably differ. And then we have our debug statement saying that the data file was read, the lines read was 4, which matches our experience there. So now the report function, all it needs to do is call the str function of the student object to print them out. If you feel like it, while I'm wandering around, add a report function that uses a for loop to print all the elements in the self.data list. Take a stab at it if you want. So something that was pointed out to me is that if the file you specify does not exist, you get error messages even more than should have been reasonable. So one of those error messages is saying that file name does not exist. And the reason for that is because we put this self.filename inside only the else clause. Which would be okay if we made read data fail if that file does not exist. So we should have an if statement here that checks to see if the file exists. And then return if it doesn't. Above this file equals open self name, we're going to add one more check. No, we're not. We're just going to leave it. It's going to be broken. Sorry. All right, let me wander around now. Continue wandering around. Yes, sir. You had it. All right, guys. There were two places where I needed to add self.data. And ironically, the debug message is crashing your program. Don't do this. Make it len parentheses self.data. That's a change I made. Not everybody caught me doing it because I didn't point it out long enough.
Did you also have self-driving?
And yeah. Also right there. That was the other occurrence of it. So the last thing I want to do is add a report function to my class. So here I'm going to, before the comment that says end report class, tab def space report parentheses self in parentheses colon. And all this needs to do, I guess we could make sure that we have some data. We could check the link to the list. So if len parentheses self.data in parentheses equals 0, it's a problem, and let's print it out. Print no data to report in parentheses, in parentheses, else colon, we're just going to use a simple for loop. For E for element, S for student, for S in self.data colon, print parentheses S. And if and report method. Report has no attribute file name. Oh, because I was trying to demonstrate what happens if you have a bad file name. Alright, it's really bugging me that it crashes if we have a bad file name. This was bad programming on my part and I have to fix it. So up here where it says self.filename equals file name, cut that line. And paste it above the if statement. So I went to the report class and I took a line that was right here. It said self.filename equals filename. Cut it and paste it so that it's the first line of that method. Lined up with the if statement and the else. And now down here we need to validate that that file actually exists before it blows up. We could just enclose the whole thing in a try except block. It's a cheesy way to do it, but why not? We've already seen how to check the file name there. So let's demonstrate the other error handling. Try this. Try colon tab file is equal to open self.filename. And if we get an error, except colon, print cannot open end quote comma self.filename, and then return. We're just going to bail. If we can't open the file, we're in deep trouble. So we're going to bail out of the function with a return statement. All right, there. Lisa's not blowing up. Report error cannot open data1.py, and then the report error, the second one reiterates that cannot open data1. We could add some kind of function, is good data or has data or something like that, so that we could check to make sure we actually read some stuff. This read data should return a true or false based on how many lines of data that it read. So why don't we make this a return 0 here? or even a -1. We didn't read in any data. And then down here at the bottom of this read data method, we're going to add something that says return len self.data. So way down here, after we close the file, after we print our message, return len parentheses self dot data in parentheses, right? Return the number of records read. So we could use that information down here, right? We could store that result as read data, you know, and then we could conditionally call report. But report is also handling the idea of no data, so I'm not going to put that check in there. All right, I hope I didn't break y'all's code doing that. Now let's call the report function, rpt dot report parentheses in parentheses. No data to report because I keep forgetting to change the file name back to something good. All right, student object has no attribute name. Is that so? Did a while ago. Where did my name line go?
That's what I was telling you to delete it.
I deleted some things and now they're, okay. These lines had better not be gone on yours, but they are gone on mine, and thank you for pointing that out, and I'm sorry I didn't fix it at the moment. I'm really surprised I was able to keep this going. This needs to say, right up here, as the init method of the student class, and you probably already have it, self.name equals name, and self.sid equals SID. So what's going on now is complaining that it can't calculate a sum of the score list. And that's a valid complaint because it came in as an array of strings, as a list of strings, and we never changed it. So when we set our scores, not only do we need to do that, but we need to convert it to a list of numbers. So we're going to modify the set scores method. Not just copy the list into it, but to use list comprehension to convert them to numbers on the way. So, next line. And in fact, we're going to wind up deleting this line, but I'm going to leave it there just as a reference. Self dot score list equals open square brace float parentheses x end parentheses for x in self dot score list in square. That copies the list and turns it into floats at the same time. My mistake. Take the word self off of that one. Or if you left that line there, then we could uncomment and it would start working. But go here, take that self dot. Big change, folks. If you typed in what I typed, it's not going to work. Make sure it says exactly this. Self dot score list equals float x for x in score list. And there we go. There's our report. Looks lousy on my screen because of my font size. It'll look better on yours. if we did the good thing and put this code down here in a main function so that it was not being triggered automatically every time it was imported, then we would have a student class and a report class that we could import into another file. So just to polish this off, we're going to do that. Right here where it says report equals report and all that business, DEF main, parentheses in, parentheses colon, and then tab those 3 lines over. Report equals report. Yes, sir.
Some people have processed things
I've been going too long?
A little bit. You're 10 minutes over.
I'm 10 minutes over, for Pete's sake. Alrighty, I was having way too much fun. Undo that last change. Lecture done. And I'm sorry that if the last change did not work for you. Let's stop that there for Pete's sake. Thank you, guys.